Hello everybody and welcome to today's webinar on electrical insulation films. My name is Thomas Letter and I'll be guiding you through this session for the next 20 minutes. Please feel free to submit your questions in the Q&A section. We'll answer these at the end of the presentation. You'll also receive a copy of the slide and a recording of the webinar afterwards. So let's have a look at today's agenda. First, we'll look at why electronic insulation films and look a bit at the types of insulation materials that we use, a material comparison, and last but not least, the possibilities for customizing these materials. At MikroPrint, we have three key approaches to insulate or isolate electronics depending on the application. The first one we look at is internal insulation or insulation from within. It can either be used as a part that serves as a dielectric barrier or insulator for electronic components, or it can serve as a thermal insulator or isolator for electronic components. The second one is a keypad stack-up insulation or insulation within a keypad, where it's primarily used for ESD protection, where the user interacts with a keypad, and this is to avoid short circuits. It can also be used for EMI shielding purposes in the keypad if it contains a display. This can be to prevent image distortion, signal loss, or black screen, which is crucial for medical, military, and automotive applications. And the last one is insulation or isolation from the outside, or external insulation. This is where we use a separate metallic housing mounted on top of some components on a PCB to shield the system from external electromagnetic interference. We produce all of these solutions in-house, but today we'll focus on the components that act as a dielectric barrier and insulator. So, we are seeing more and more power electronics everywhere. Electric vehicles, of course, but also products within industrial automation has now gone fully electric, replacing most mechanical, hydraulic, and pneumatic systems. And as more things go electric, we're also seeing more battery-powered functions and higher voltages being packed into even tighter spaces. That's exactly where electronic insulation becomes critical. It's not just a layer of material, it's a safety system that keeps current where it's supposed to be. And to prevent failure like this, we look at isolating electronic components and materials from each other. As shown on the picture here, you can see that the electronics component are isolated by the insulation material here against the external outside metallic housing. This is the primary function of insulation films. And to put it simple, by isolating electronics, we avoid short circuits and the potential risk of flame spreading. So, let's have a look at the typical material used as a dielectric barrier and insulator. The materials we'll go through today is the most typical used material by MikroPrint. But there are, of course, a lot of other materials also available. These are the three typical materials that we use in-house. First is the polycarbonate. The second one is a polyester. And the last one is polypropylene. When looking at the electrical properties of these materials, you'll typically refer to a UL yellow card, which can look something like this. However, for some people, it can be quite detailed and difficult to navigate. So we've extracted and highlighted the most relevant properties specifically for electronic insulation applications, which I'll go through now. So we purchase materials from the leading manufacturer of insulation films, such as Lexan, Mylar, DuPont, and ITW Formix. And under each here, I have listed each of a brand and type for a polycarbonate, a polyester, and polypropylene. For the polycarbonate, we use the Lexan FR60, where the FR stands for flame retardant. For polyester, we most commonly use the Mylar A from DuPont. And when it comes to polypropylene, we use the Formex GK from ITW. One of the first requirements that customers normally specified for insulation film is the UL94 rating. It is part of the UL 746C testing, and it evaluates the polaric material used in electronic devices. It states the fire behavior and resistance by testing against ignition and burning time. And the thing to notice here is that the lower the value, the better the flame resistance. So here for polycarbonate, we have the UL94 VTM or V-0. The VTM is for the thinner materials, and when it becomes above a certain thickness, it's the V0. But same properties when it comes to the value you're looking at here. So for polycarbonate, V0. For polyester, can only achieve the V2, so the higher, the worse flame rating. And also for polypropylene also has the V0. And going even further into the electrical requirements, we can look at dielectric strength, which is the maximum electric field a material can withstand without breaking down, so without becoming conductive. Simply is a measure of how well a material insulates against electricity. So you can see here the dielectric strength is usually expressed in kilovolts per millimeter, as performance depends on the thickness of the material. And in fact, the thinner the material you have, the better the dielectric strength values. So as you can see here, polycarbonate for the specific 0.25 millimeter thickness, which is normally used for most of our parts that we produce in-house, it has a resistance of 15 kilovolts for polycarbonate, 19 for polyester, and 22 for polypropylene. And going even further into these electrical requirements, we can also look at the hot wire ignition and the high amp arc ignition, which these stands for. And these values are given in a PLC or stated as a PLC, which is a performance level category. And they can say that and here also in opposite the other, that the same as the UL94 rating, the lower the value, the better, and the higher the worst. So and also you can see here that you need to pay attention to that the Mylar, when it has on the thinner gauges of Mylar, it actually has a pretty bad rating. So this is something to consider if you're limited in the thickness of the material. Yeah. But also we can look at 3 other parameters here, like operating temperature, moisture absorbance, and chemical resistance. As you can see here, they're pretty similar, but we have the worst performance and temperature on the polypropylene, where it only goes from -40 to +115, where at the polycarbonate definitely has the best performance when it comes to operating temperatures. Also, when it comes to moisture absorbance, polycarbonate actually absorbs water. Polyester is slightly hygroscopic, so it means it absorbs slightly moisture or water. But polypropylene is highly resistant against moisture and water absorbance. And when it comes to chemical resistance, you can see it gradually becomes better here. So polycarbonate has a so-called fair resistance, polyester is good, and polypropylene has excellent resistance. And in fact, when it comes to the dielectric strength performance, thickness and humidity and temperature can all have a significant impact on this. And now I'll just show you some examples of how it can affect. This is measured on a Mylar material. So you can see here we have the dielectric strength versus the thickness. So as I mentioned earlier, the thinner the material, the better dielectric strength, which this is a pretty good example of, where you can see a thickness of between 5 and 10 has a dielectric strength of almost 800 kilovolts per millimeter. Where when we move down to the most commonly used thicknesses around 250 microns here, you have a dielectric strength just below 100. And also, as mentioned, the dielectric strength can also be affected by the temperature. So if you see here for the different thicknesses, let's just take the 50 microns here. You can see at 0 degrees we are a bit above 200, and when it goes all the way down to 150, it actually significantly drops 75 kilovolts per millimeter. So this is also something to consider if it's a high temperature environment and you have very specific requirements for the dielectric strength. And again, humidity, maybe it's not so necessary. Maybe you have control of the humidity inside your electronic assembly. But if you are moving above the standard relatively humidity, then you can see at 80%, it starts very low, also depending on the thickness here. And actually, it's 200 something, where at only 35 relative humidity, we're at between 200 and 300. So also something to consider. All of these parameters combined together could be relevant to look at when evaluating the need for your dielectric strength. So one thing is to look at the functional properties of these materials, but we also customize a wide range of parts for our customers. So we do this by adding prints, bending them, cutting them into shape, applying adhesives, and other customization options. Now I'll give you an overview of the 3 materials presented earlier and their customization possibilities and the focus point for each. So here, the first one is polycarbonate. And for the first customization option is normally that the customer wants something to be bended into a shape so it fits inside a housing or to cover a certain electronic components or a PCB. And here actually the polycarbonate has excellent performance when it comes to bending. It holds creases and bends without any spring back, so it's pretty good for holding a certain bending angle. And when it comes to cutting it into shape, we either can die cut or laser cut it. And for die cutting, polycarbonate shows very good results without any edges sharing or any edges that are not nice cut. But when it comes to laser cutting, it's not very good. Polycarbonate is also, as mentioned earlier, it has a very good fire rating. So by laser cutting, it's actually trying to burn it. It would try to resist being burned. So the edges might melt a bit, not creating a very nice edge. It can also discolor if you have light or bright material or colors on the part. And when it comes to printing also, it also has a low to moderate surface tension. So this is where, like this example on the picture here, we added some print to it. You might need a primer or a special ink with some hardener in it to make the ink stick to the surface. And when it comes to adding adhesive to the part, we can also use our standard adhesives. For polyester, for bending, this has a moderate to high performance. It forms easily, but it also tends to spring back unless it's heat set. So we can also use heat to make it even sure that it stays in position. When it comes to die cutting, it's excellent. It also shows very good performance like the polycarbonate. For laser cutting, it's also good, but we have to be aware that thin gauges might discolor and slow down process speed. So the best and optimal thickness for us to process is the 0.25 millimeter, which is the one we use the most. For printing, it also has low to moderate surface tension. So we know here it can also be hard for inks to stick to it. So we might need to use an ink primer or a special ink to make it stick, depending on the requirements for it. Again, here we can also use standard adhesives. And when it comes to polypropylene, here for bending, it's low to moderate. Polycarbonate is a very soft material and it's very flexible, so it's very hard to hold these bends. So you need to do some kind of mechanical fixation or bend or something else to make sure that the bend stays in place if this is a requirement. But for die cutting, it shows excellent performance also. It's very easy to cut and shows nice edge results. For laser cutting, again, like polycarbonate, it's also very poor. It also has the high fire rating, so it will also the edges would tend to melt or discolor if it's a light material. And for printing, due to the very low surface tension on polypropylene, it's very challenging to print. So here we really need to be aware of the need for ink primer and maybe hardener into the ink. And the same for the adhesive. We know that there are special adhesive made for LSE surfaces and especially polypropylene surfaces. So here we actually need to use a non-standard and a more special adhesive to make it stick if that is needed for the part. So as you can see, we offer a wide range of materials and processing options to help you find the right solution for your specific need. While these parts may appear relatively simple, they play a crucial role in overall performance at your final product. That's why we don't expect the demand for insulation films to decline. On the other hand, as mentioned earlier, we're actually seeing a growing need for these types of solutions. And we have a production setup that meets your requirements. Whether it's a simple part with a single bend, or it's highly customized with more bends and 2 parts put together, or even added adhesive pads, we can support. And we can also scale it accordingly in our production. We also support early stage development from prototyping to high volume production. And we have the best cost production options for each of your specific design and requirements. I hope this webinar helped you clarify your options and made it easier to evaluate materials to choose electrical installation going forward. To wrap this up, we put together a checklist with the key questions you should consider when designing your next insulation film. So let's just run it through. See, first of all, as mentioned, the most commonly stated requirement from the customer is the flame class. Which UL 994 rating are you looking for? Is it the V0 or the V2? Which environment is it used in, or device used in? Is there a specific requirement? Is it a high temperature or a low temperature environment? Is it very humid? As I showed you on the graphs, that this also affects the properties for the dielectric strength values, for example. But also consider the design requirements. What are your dimensions and the tolerances, especially for the bends? And also looking at the bends, we can also look, is it allowed to, if we use a very soft material like the polycarbonate or the polypropylene, and you have a requirement of the bend staying in place, we might ask, is it okay to perforate the bend? But we also know that this can affect the isolation level as we perforate it. But this is a way to make it, the bend stay in place. Do you need printing on it? We also need to consider here what type of ink and printing method that you use. And again, also a bit of insight and to share with us for the assembly requirements. What are the mechanical fixation? Will the isolation film be mechanical fixated by some screws or screw towers, or do you need the adhesive pads to make it stay in place or to adhere to certain areas inside your cabinet or mechanical assembly? So that was a quick checklist that you can consider for the next time, as mentioned, when you're designing your next insulation film. And we will, of course, be happy to help you, guide you through these questions, and also help you specify some if you have some very specific requirements we have not covered at this webinar. So I think it's time to move to the Q&A. Let's see what we got here. So I'll just try and find some here. Oh, a lot of good questions here. So let's just see the lectures. Yeah, so we have an answer here, just a follow-up question. So you can see, is the dielectric strength graph of Mylar saw the thinner the film, the higher the dielectric strength. So thinner means higher voltage resistance. This is also intuitive. Do I misunderstand something? No, that's actually right. We are seeing the better dielectric and voltage resistance for thinner gauges. But of course, when you're talking it's because if the thinner the material, the less risk for air trapped inside or deformations in the material, and this very much affects the dielectric strength. We also see the thicker the material it becomes, there's the risk of deformations inside the thickness of the material, which can affect the dielectric strength. And it also has a tendency to become more hot, and the temperature also can affect the dielectric strength. So that's also, the thicker the material, the more absorbance of heat, for example. So that's, as I showed you, the temperature also affects the dielectric strength. So that's where it also can affect it. But as an overall, rule of thumb, the thinner the material, the better the dielectric strength values. Yes. But that's where you have to look at the hot wire ignition values also, if this is a requirement, because this also shows the properties for a hot wire burning through. So here, if you have a very thin material with a high dielectric strength, it might be easier to penetrate or burn through it. So that's where you might want to have a thicker material. Yeah, no. So that you need to combine the more parameters, not just look at the one. But yeah, it's correctly understood. Yeah. Yeah, we have here, as I just mentioned, what does the HWI and HAI stand for? And the HWI is the hot wire ignition, and the HAI, it's hard to say, stands for the high amp arch ignition. And these are all values you can also see in the yellow card for each of these, which is normally the ones that are specified. We're also getting asked here if we can vacuum mold a cover. No, unfortunately not. This is not a process we have in-house. So that's normally where customers come, that sometimes we have very, very complex shapes that needs to be shaped like something that's even that can be vacuum molded or even injection molded. And that's normally for if it's a low quantity or you want a reduced cost for it, it can be very costly to do an injection molding part. And that's where there's the possibility of using a material and try and bend it into the shapes that you would like it to be like. So I think, but it's still from a flat 2D material. Yeah. Yeah. Let's just see. Oh, sorry. Yeah, we also have a question here, if it's possible to use a film to make a fire enclosure where potential flame will be diverted from other parts. Yeah, if I understand the question correctly, yeah, it's about limiting the flame and I don't really know if it's actually diverting it, but if you have a specific components where there's a risk of creating a flame, you can isolate that specific component to ensure that the flame doesn't reach the surrounding areas. But we have, if it's a very high voltage we're talking about, and we're talking not just an ignition or a small spark, but it's really flames and fire comes up there. There's also other materials that are available, and here if that's a requirement to divert actual fire or flame, I would recommend maybe looking into something like the 3M flame barrier products that actually has a UL 945VA rating, which is 5 times the V0 when it comes to the flame rating. So that could be a possibility to look at this. Yeah. A new question has been asked. Yeah. Yeah, we also have a question here regarding what to be aware of using these materials near ESD sensitive electronics. Yeah, that's also as one of the slide, the first slides I showed. This is normally when we're talking the ESD, it's normally from the outside we are working with protecting. If it's protecting our ESDs inside, the components are I do not believe there's any considerations or any risk of using these materials to ESD materials or ESD sensitive components. They are normally used to cover electronics and other ESD sensitive components. So they're specifically developed for this. So there shouldn't be any risk of something to be aware of here. That's more, yeah, as mentioned, we could put it as a layer inside, combined with other materials and solutions for leading the ESD from outside away before reaching the underlying components. Yep. So I think that's it. We also used most of the time now, actually, plus, yeah. But I think some of the last of the questions I'll answer them later on, and we'll reply them by mail. So we have your contact information here, and we'll answer these questions here. So thank you very much for joining this webinar, and hopefully, as mentioned again, you learned a bit more about the possibilities within insulation films. And please use 1 minute to evaluate the webinar afterwards. We really appreciate it. We always want to improve. So if there's anything we did not cover or anything we can improve, no matter what it is, please let us know, and then we can improve. So thanks for now. Have a great day.